Okay, hello everybody, and welcome again to our webinar series on how to use the Columbia Basin Water Hub. As I did yesterday, I would like to begin by respectfully honoring and acknowledging that I live and work in the traditional territories of the Ktunaxa, Secwepemc, Silks, and Sinixt peoples. Well, today we're going to cover provincial water standards. So that's going to be a very wide overview of the manuals, where to get them, and what they talk about for the resource inventory um, um, survey. And I forget what the other two letters are for there. And then we're also going to look at how quality control is carried out, a little bit of formatting, and how to meet our Waterhelp certification steps. Also our metadata schema, and ultimately how to upload data. All right, so let me just pull this up really quickly here and share my screen. All right. So as I said before, we're begin with our provincial, or actually before we start, I'd like to mention that today is going to be recorded just like yesterday for future reference. And you can either work along with me with the data that I've provided with the links on the right. There you'll find the data upload template for water quality, the data upload template for hydrological data sets. You're also going to find a variety of sample data that I found. And that's what I'm going to be working with today. However, you're also able to just watch me do what I do as I go along, think about questions about how could this apply to your own data sets. And then, yeah, if you also want to do this yourself, please feel free to do so. And then, yeah, just please hold your questions until the end, or write them on the chat box. And also, today is going to be a little bit more technical. It might take a little bit more time. And there is a lot of information that I'm going to present to you. And so please don't feel overwhelmed, as this is just an introduction, a very broad introduction as to what we can do, what the Waterhelp can do. Now I'd like to talk to you about the risk standards and the available resources that we have in order to grade data to a provincial standard. So when it comes to water quality monitoring, there are two important resources that we use, that I use in order to create our approach for water data quality. So first is the continuous water quality sampling programs operating procedures. This manual just really looks over everything for automated sampling, specifically how to carry out QA and QC protocols, all the metadata needed, how to collect samples for lakes, streams, and effluent waters, and basically everything has to do with water data for both, for only automated processes, so using sensors, how to deploy them, and all that. And then for the part E, the water and wastewater sampling, ambient freshwater and effluent sampling manual. This is more around how to collect samples manually compared to over time. If you'd like to check them out, I will provide all of these links at the end, and you can find them there, or a quick Google search will do the same. They're under the aquatic ecosystems. And now looking into water quantity, what we have is a manual of British Columbia hydrometric standards. This manual is designated to guide different data grades and how to achieve them and how to grade them, standards, station design and deployment, as well as stage measurements, discharge measurements, stream ratings and computations, and the start and process and to how to review that. This is going to be, again, a very brief overview as to how I approached the necessary steps in order to be able to have our data QA QC'd by a professional hydrologist or a professional. So how does the Waterhelp handle data quality? Our current approach is to ensure that data that we provide is of certain quality in order to be used for climate change studies, water balance studies, and evidence-based decision making. Is to use a standard upload template for water quality and water quantity datasets is how we're going to handle provincial datasets. So when the Water Hub is released, a complete QA/QC protocol will be released, where we outline every step that we take to do the best that we can to provide useful, quality data for different needs. By taking this approach, we also ensure that the longevity and preservation of data endures, as it will contain complete information about who, what, when, where, why, and all other metadata needed. Okay, so now we can look into the templates. So a little bit of a backstory about our templates. While exploring similar databases to us, I came across DataStream, and they are one of the main repositories of water quality data in Eastern Canada. Their approach is an adaptation of the WQX standard that was developed by the US EPA. They developed a workflow for uploading data, which includes a template. So they gave people a very strong box, and they're like, put your data here, and this is how we're going to go. However, building on this approach, I decided to modify the template to fit the necessary information outlined in all the manuals that I talked about before. However, I didn't want to restrict everyone to have the same template. And so that's where we're opening our door to figure out, first of all, how and what defines water quality within our basin. That's something that I would like to decide collectively with everybody so that we know what that quality is and we can accept what that is. And so that's going to be a collective agreement while we're developing this QA/QC protocol, and again, being an iterative process where we get the feedback needed in order for us to have a collective idea of what that looks like for us. Okay, and so now before we start, I would like to introduce a little scenario. We're going to put our data environmental monitoring hat on, and let me just get my hard hat, which says dataset building. And so this is what we're going to be wearing today. Awesome. All right. So in our project, this consists on collecting water quality data with samples, a temperature logger, a discharge dataset, and climate data. And sorry, this is not really working, my headphones, so it was more for show. I don't know. Can you hear? So we're looking for a discharge dataset and climate data. We are then meant to format all that data to fit within the Water Hub for upload. And we also have a report to upload alongside with that with all of our data. In order to access this data, however, I have provided all of the links on the side, and I had to do a little bit formatting on my own. And whenever we look through the data sets, I'll mention what I did to each data set before presenting to you, as well as where I acquired it. Okay, so now that we have that out of the way, let's just share my screen, we're sharing that, and bring it up. So first, I'd like to walk you through our continuous water quality monitoring template. And this is what we have so far. This is where you will arrive. And before we get into it, please, again, if this is a lot of information, don't feel overwhelmed. I'm going to walk with you through every single step as to how to do this with your specific data so that we can take a good approach and manage this properly rather than just kind of throwing this at you and you having to figure out on your own.
Santiago,
So, yeah.
Can you zoom in?
Oh, yes, I'm sorry. I had my Waterhelp also in there, but I forgot about these.
Great, thank you.
There we go. Thank you, Nicole. So here's where we arrive. First, this is just a little word about Excel compatibility and having Power Query on, because we reference different cells for automatic reload, so they reference each other. What is this template for? Basically explaining what this is used for and how it is used, how to use this template, so specific steps that you should take in order for you to complete this. And again, this template is only for data that needs to be graded in order to meet risk standards of the province of British Columbia. And so these are not the templates that we'll be using for every single water quality data set. However, we're going to develop simpler, way simpler templates that we can use that will be perhaps unique to your organization or more general. This will decide again as we continue to mature and see what the needs are. If there is need for that, then we'll develop them. If there's not, there is no need to develop them. But back to this. So if you can see, here's my cursor. I put a little circle in the middle. So there's all these steps as to how to complete this. And I'm not going to take you through them because I'm going to talk about them. And then here at the bottom, we have a color-coded legend. So this will show up whenever there's corrected data. This is required data. So you'll see there is a lot of required data that needs to be filled out. There's optional data. So this is data that we deem to be optional and would not be required to have, but strongly suggested. And then there's not required data. And then we also color-coded different categories. We have dataset information, which will relate to the dataset metadata, which are the same fields that you find in our CCAN upload page, which we will look at later. Then we have monitoring location data, characteristic details. So talking about what kind of activity was taken on, and then details on our results. And then as you may see, I also have here a link so that you can check out the original water quality template the data stream created. And then yeah, and as you can see, export is within our first sheet. And this is because, again, our CCAN will preview this as the only page that's present within our file. And so let's get into this. So in order to complete this, I have a water quality data set right here, which I blocked out the name, but thank you very much to the person who gave this to me, that it wasn't sure if I could share it or show it, and so we'll leave that in privacy there. And so this is, let me make this bigger. This is a certificate of analysis for water samples. And I assume that some of you may be using this kind of lab analysis to determine different analytes that are present in your water. And so here, to begin with, we'll know that this page will not translate nicely within CCAN. This is our first page, this cover page, there is no headers, and so this wouldn't work for us. However, it is full of information that we can use to put it within our water quality template. So this is a summary that right now we can skip. And this is what we're more interested on right here. So we'll go back to our template first and see what we require. On page 3, we have a allowed values section. And so here, as you can see, the fields at the top with the headers are all color-coded depending on the different aspects that they'll be covering, just for easy reference. And then they'll have all of the different allowed values that you can use within there. And a word of advice when filling these out is that because there is a lot of formatting that goes into this, when you copy and paste or paste values, please make sure that you select only values when you're pasting. As if you paste just regularly, it might bring in different functions and take over that instead of having the references. And so it might just mess with things a little bit. And so here we can really see a really good description of what we can use. And then when even a step further, and we have a brief description of what each field within this template is. Now, let's go into our dataset metadata, which is the first place that the instructions tell us to go to. So first we reviewed the sheets, and then we go and put in our dataset metadata. So our dataset, we're gonna call it the Santi project, because this will involve the whole data set altogether. So we're talking about our project here rather than the specific resource at this specific moment. We'll see what we'll do when it comes to resources when we're uploading this data. So this is Santi's project here. And as you can see, it already turned to green. So there's some nice formatting to make sure that you're filling out all the necessary fields. And then the contact email is going to be me. leave it up, and it doesn't have to be right now. The data upload organization, we'll call it the Water Hub abstract. So this is a test, but here you just put in, a description of your data set, its purpose, and the nature of your monitoring effort. So why are you carrying this on? I think this is a great field to have because it will give us a great perspective as to why this was really used rather than just a description of what's in the data. Data collection organization. I took this from a variety of sources. And so here you have to either see with the collection organization in terms of how they would like to be cited and referenced, whether that data belongs to you or not. And so that would really depend on each case. So in this case, I'm just going to call it Santi again for the sake of time. Data collection information. So this will talk about your methods. So I consider this somewhat very, very important. And I would put it under the red, but I also didn't want to have everything completely red. This will really be hugely important when it comes to data grading and for us to better understand why this data was created, for what purpose, and what it includes. This will have everything from QA, QC that was carried on the data, as well as any computations that happened from the raw data set to the displayed data set. So here, just, again, testing. So the data processing, again, once again, more detail as to what happened to this data when it was in your hands and if there was any change from the original raw data. Other data sources, if you decide to amalgamate from different sources, so this is where you get a chance to cite different sources for your data. And so here, I got a couple from BC Hydro. There's one from Living Lakes, Canada, and so on. And so here is where you really get a chance to also highlight others that you may have collaborated with. Licensing and attribution. So in this place right here, you get to choose from 4 different licenses that we have available. You can either pick from the Creative Commons Attribution Non-Commercial Share Alike. This means that people will be able to use your data for non-commercial purposes, and they have to give you reference, so they have to reference you. Then we also have the Creative Commons Attribution Share Alike. So in this case, if you are okay with your data being used to create other products and you are not necessarily looking to have a remuneration for that data, yet you still have to be cited, then this is the license that you pick. Then we also have the Creative Commons 1.0, and that is completely open, universal, public domain data. And with this data, it's basically out there and it's open and there doesn't have to be real attribution to you. And so I would pick this one very carefully as it opens anyone and everything to your data. However, we make sure to display that none of us are liable for the data that we display and the uses that the data is for. Lastly, we have an open government data license. With this license, we're only really apply for now to government data sets that we put in the data set through links. And so unless you work with government and work under that license specifically for some reason, please stay away from that one. The one that I would pick the most and that we have a standard is the non-commercial share alike, the attribution. And so that's the standard one that we're using right now. And so here we can go with CC by and see. Okay. And so here's the data disclaimer where we say that there was no QA/QC carried on for this data. There was nothing else done to it. For here, we can explain that this data set contains a variety of resources which were formatted in order to allow for previewability. Okay, so that now takes care of our metadata. Now we can go on to, oh, first I would like to show you something. As you can see, our first part of our export got populated with our dataset name very easily and quickly. There's no need to do anything. It's already there and done. Now we can go on to, excuse me, our monitoring locations. So now we can go back to, I totally realized I kind of messed up. I was going to use the metadata from this data set here. My apologies. Or we can go back and start using this again. Okay, so for our monitoring location ID, here we can use what we have here, as we have four different creeks. So we can call them 1, 2, 3, and 4. Here's 1, and 2, and 3, and 4. And I'll have to look into this to what's doing that. And then our location names, we can go back as well and grab all our location names. All of our location names. Great. There it is. And then fun trick with transpose, and we have our monitoring locations names easily there. Then we can grab a location, latitude, and longitude if we had them quickly and populate them. And so let's see if our data set here gives it to us. So we don't quite have it in the detailed report. We also don't seem to have any coordinates. And I looked through it and we don't have any coordinates. So, okay. So here, if you were the program manager for this project, you'll know the locations of your monitoring locations. And so just for the sake of quickness here, we can just call this Kasigar is around 49 something. And I believe like minus 107 or something like that. And then what kind of coordinate system are we using? So it's a good opportunity for you to show and be able to use a variety of different coordinate systems. And we have a whole variety here. So right now I'm just going to pick 93. Monitoring location type. This refers to what kind of water body we're looking at. And so these are rivers and streams. So river and stream. Monitoring location deployment. So this is now getting into what is required from the risk standards. This will include as to how the station was designed and deployed, and then the equipment that is there, the station log available. So there are logs and forms that we can find and I'll make available in our resources for you to be able to fill those out. And some of you may already have the risk forms available to you and fill them out from the beginning. And if that's the case, then our data should be good without having to put it within this big template. Because what this template is meant to be is the forms that are required to fill out in an Excel sheet for ease and convenience. And so we can put all that within our Waterhelp. Okay. So I'm not sure about this deployment. So here we can say, whatever takes care there, our equipment. Let's see if we have it here, how we sampled our water quality. So because this one is not there. So here we have a variety of different, just to show you different options for you to put there. So was this an electrical sensor, electrochemical, optical, or portable? Yes or no answers for the station logs, and the same for the risk forms. Here you'll be able to select from either the 1, 2, 3, 4, or none. Now we can move on to our characteristics metadata. And so here, when we go into our data set, we can see that in our detailed report, we have the analyte, and there's different analytes that were tested here. And so what we can do is go here And then we have a total of, let's see, about 230 there, plus a little bit more total analytes samples for this. So today, let's just work with one and grab, let's grab nitrite as N as our example here. So we know this nitrite as N. So it's going to be our number one under characteristic ID. The activity type. This is a field measurement of observation. As we went out there, grabbed a water bottle, filled it up with that water in question, and send it into our lab. Then you also have a variety of different choices that you can use, like quality control alternatives, replicates, samples for equipments, field replicates, and so on. So because this is just a field measurement of observation, our media name, then again, this is our water body here. So this was surface water, and then the equipment that it was collected with. And so here, you just grab a water bottle, but you'll know more as you know your data and how it was all collected. And then just making sure that we're not kind of missing things here. That could go on there, okay. Also here, okay. And go back to our water quality template. Was this a portable probe? No. And so if we went out, for example, and this was not part of a continuous water survey, but rather you going out and having a multimeter, for example, like one of the YSI ones, you just click yes, write the name of the probe, the manufacturer, the model number, the parameter that you're measuring, the accuracy, the resolution, and the range. All this information is very easily accessible through the user manual that you should have, or in whatever manufacturer's website that you have. And so here we can skip all this since we are not using a portable water meter, and go back to now our characteristic name. Here we're looking at, I believe it was nitrite as N, nitrate or nitrite as N. See something with values. Okay, let's use nitrate as N. So here we can go to nitrate, and it was part of our allowed values, so this will turn on as green. If there was something different, you wouldn't be able to see that in green. Now, the method specification. Here is where we see what are we seeing our characteristic as. And so as you can see previously in our other data set, here we have nitrate as N within the same cell. This can get a little bit confusing, and we want to divide those two fields. So this is as N. And again, you have various different options for various different compounds. And as we mature more and we see the needs of the basin, there's going to be we're going to be revisiting this quite often with your feedback in order to make sure that we're meeting all your needs. Then the result sample fraction, we have to go look and see if that's given to us. So it is not given to us here, maybe in our methodology. And for nitrate as N, inorganic ions are okay. So go back here, extracted or filtered, lab, result unit. Now we can go back to our detailed report. And our units are in milligrams per liter. So we can go over here, and we have given all these different units for us to be able to use. So milligrams per liter. Our result value type. So was this actual, it's blank, calculated, control adjusted, or estimated? And just gonna go with actual here. And sorry, that should actually be calculated. this is our detection quantitation limit measure. So this is where is our limit for detection? And we're given that within here, where there's a detection limit for nitrate is 0.0005. Copy that, and then we're going to do the paste as values. And our unit here is also milligrams per liter. Our type, method detection level, result analytical method ID. Here, this one's a little bit weird, but it refers to this method right here and this code. And if you'd like more information about them, because there's a lot of different methods and information, that's something that would be more applicable to you as a single user there. And then again, we can go back, put there. And then for the context, we can go back here, methodology. For our reference, this one right here, copy. And is from the US EPA. So we can see if we get this value. The method name that was also given to us. And then the laboratory name, which is also given to us, right, in our cover page, somewhere. I don't see it. But you have your laboratory name on there. Okay, so with that out of the way, you repeat that process for every single one of your analytes that you look into. Now, this can be a little bit time consuming. However, the first time that you do it, you're done with it, because if you continue looking into the same parameters, you're going to be using the same template and it's going to look the same. And this wouldn't change unless you change lab, the methods change, the limits change, or any of those things. Now, looking into the results, here we have our monitoring location ID as number 1. I'll just zoom in here real quick. Our characteristic ID being 1. The start date, let's say it was today, so our format there is 2020, month is the 12th, and the 16th. Start time, here we put it in a format of hour, minutes, and seconds. So let's say it's 12:37, and you know the seconds, it should be kind of weird to put into seconds. And then the end date, so let's say, let's change this to yesterday. Change this to today. End time, again, 12:34. And now we're looking here at our activity depth height measure. So let's say you're putting a sensor into the water. What is the depth of that sensor? And so here, this is in meters. And we just put it, let's say it was at 0.5 meters, half a meter down to the water. And you can also put here your units. And as you can see, I'm also having issues with our conditional formatting here for some reason. And again, it's a good reminder that we are a work in progress, and we will continue to work in order to meet the standards and the needs of our communities. And then here is a result value. And so if we go back to our example from our detailed report, our results were less than the limit. Oh, sorry. Yeah, so they were actually above the detection limit. So we can copy that right there. And for the dates, we should have used what's here for the date sampled and the time and all of that. And so that is given to us within this. And so again, that would very much depend on your data sets themselves. And also see that I'm kind of running short on time. So I'm going to try to go through this a little bit quicker so that we can look into other types of data and actually upload this. So our value here, we're just going to paste it as a value, the condition. Is it above, below, or where is it within our detection limit? So it's above the detection and quantification limit. The status ID, is it validated, accepted, final, preliminary, rejected, or validated? So we'll call it accepted. Any comments that you may have about this sample in specific? This may be comments by you or comments by your lab that you can put in here. The start date of the analysis that we could grab from our original data set. The analysis start time, the start time zone, where we also have a drop-down menu. You can pick this. Laboratory sample ID. We'll go back into our data set, and it will be our ALS sample ID. Just grab this, copy it, and paste the values. And you can repeat that process. And then when we go back, as you can see, our data has been mostly populated what we've put into our cells. And I'm zooming out a lot so you can see that most of our first row, which I'm really what I'm interested on, so we can see at least a little bit of a preview when we upload it. So we have that first row already there with all that we have and that we've put on. And now we can just click save. And that's ready for upload. Again, this is a very rough and overview walkthrough of the water quality. This will very much depend on your individual needs and your group's needs or your community needs and where the data needs to be. Okay, so with water quality out of the way and saved, we can minimize that. We can get rid of this right here. And now we can look into our water quantity template. A lot of the same. And so with the first idea in mind of having standards for risk grading, I went with a very, very similar format, but you'll be able to see some of the differences as to what I did and what DataStream did, what ideas I got from them, and what I had to create on my own. It's basically the same start where you have export at the top of the sheets with the first one, and it will auto-populate just like the other one, just like the water quality one. Then I'm working on completing the allowed values, the glossary, and the dataset metadata would be just the same. I'm not gonna go through it all again, but again, this is just an overview, and I'll get more into this individually with your group. But yeah, let's keep looking into it. So just like our first template, first we have our monitoring locations. So we'll input our ID, which is just given by you. It should be numerical, or it can be alphanumerical. Then we have a stream name, as this is more specific to a stream. Monitoring location latitude and longitude, the coordinate system used. The monitoring location type, so just as before, are we looking at a lake, an estuary, a lake? So what kind of water body are we looking at? Information on deployment, information on the equipment. Stream flow, meaning which way the stream is flowing. Upstream allocation, other parameters that are measured other than water quantity. So let's say that you're also measuring temperature, pH, you name it, it will be in there. And again, the drop-down menus are not quite updated, so keep that in mind. And then the hydroforms is what kind of forms have you provided us so far that meet the necessary forms for the risk assessment. And there's a total of 5 forms. The hydrometric station history, which each form is represented here. So the hydrometric station history, level notes, water stage notes, discharge, discharge calculations, discharge summary, and stage discharge. And so as you can see, it's a lot. And this doesn't include the review form that is provided by the government as well. Okay, so now let's look into our station history. So this is where you give us all the previous history about your station. So here, this will be auto-populated from before with the blue. Any actions that you carried out for this? So do you establish a location? Do you relocate it? Do you modify it? Or do you close it? Any date of the changes? Any records collected? So what are you looking at? Primary records, backup, telemetry, or is it a logger or a sensor? Any notes that you may have? Then it looks into benchmarks, the datums, elevation, another date, so you can, if there's any modifications to the benchmark, so this is a yes or no, what benchmark that was, the date of the change, from where did it go to where did it go, and the reason for the change, who updated it, the date it was updated, the type, the date of the install, and so on. And if you're familiar with this, with the risks forms, you'll know what I'm talking about. This also then looks into the accuracy, the range, and more notes. So you can see some repeated fields here. And this is on purpose, as just trying to make sure that we're meeting every single field required by the province to create this data. And as you can, and as you'll see in the export, I didn't include every single field, but rather what I thought was important from all of this. So the results, for example, from the discharge summary, and from the stage discharge, those are things that I consider important. And so this would ultimately be what you consider important. You would put in your export field and go from there. So now moving on to level notes. Again, just for reference, you have your monitoring location name and the ID and the name and the stream name. You shouldn't have to repopulate these. These will populate themselves. The backside, the height of the instrument, foresight, elevation, just more information about your station and levels. And for water stage, again, the same three fields as I explained before, as well as every single field that is required for water state, for logging the water stage, like date, what time you arrived in your watch, and your logger, and then you're looking at the gauge heights, the three different ones, when you departed, and what the level was when you departed. Now discharge. So in discharge, here again, we have the monitoring location ID, so you know what you're referring to, when it was, and all different parameters that are in the forms. And again, I gonna keep keeping track of the time, and I don't want to spend too much time on this specifically right now. Rather start showing you a general approach as to how we can hopefully get our data created if that's what's needed. So now I'm in the discharge calculations. So this is what's used in order for you to calculate discharge. And you can take full advantage of having Excel for doing that quickly. Some of the improvements that will be made is having the calculations already put into the cells so that it can start doing the math by itself. Now the discharge summary is where you can start putting some of our results from our discharge calculations, bringing them in, copy and pasting, making sure that we're using pasting values, and then differences in between different gauges, area, velocity, total discharge, and then if there was a curve that was used, a curve table number, differences, and the percent difference, any comments, and who checked it. Now our last one with water quantity. Once again, the monitoring location ID is number one, and then the stage discharge curve number that was used, when that curve was created, who revised that curve, the date, and then more fields that pertain to that specific form. This one that's blacked out here is because it's blacked out for our difference calculations. And then I forgot to show you, but on our other template, we also have the tips and tricks that show you different things that you can do, or what you can do, and any kind of issues that may be arising. Time zone lookup, just in case you need to know what time zone you're in, which should I'll be a little bit concerned if you have to do that sometimes. Our horizontal coordinate reference system. And lastly, but not last, is our change log. And I'm a big fan of this too, because I want to make sure that we keep track of every single change that gets made to this template as we improve it and make it better for everybody. Okay, so with that now out of the way, we'll just don't save this one because our water quantity does not have to be reviewed in order to meet risk standards. What we will use, however, is the data set that I showed you yesterday from BC Hydro. Now, a quick word onto what I did here is that display of that data was in an HTML format. And it was very weird for me to grab it and put it back into a CSV so that I could work with it. So what I did is I copy and pasted it into a text file, and then I got Excel to do the hard work for me and separated by using the distance that was used in the text. And so that was a little bit technical and took me a little bit to figure out. But at the end, I got this. And so this is the date. And as you can see, it says me and then water, level, W, temperature. It's weird. And so it's going to take some changing. So obviously this is date and that's fine. This is water level. This is time. This is water level. And this is water temperature. Now we'll get rid of all of these as they don't work. We can even name this just temperature because the spaces are going to mess with us. Level. Okay. So now I'm curious about units. How would I know temperature is in Fahrenheit or in Celsius? So what I'm going to do is I'm going to specify it by inserting a new, should be there, and then I'm going to put in unit, just like data stream did on theirs. And then here, I'm just going to put C for Celsius, double click there, and all of it got auto-populated for it to be Celsius. Now I want to do the same thing for level. And so I know that's in meters. So now I'm going to put here unit, and that's going to be in meters. So go there, double click it so it goes all the way down. And now I know that my water level is in meters, my temperature is in Celsius. Now this one is going to make troubles for us. So we delete that. And now this is a perfectly previewable data set for our Waterhelp. Now, this data set would go through our QA/QC protocol to ensure completeness, making sure that all the values make sense. And one thing that I can see already is that all of these temperatures here, they kind of change as you expect them. And this is just something seen from the top. And that's where we'll look first. There's not much change in any of these, so don't seem to be any outliers. But you have to do some statistical tests in order for you to be able to figure that out for real. So now we can save that, and close it. And now I'd like to give you an example of some groundwater data. And so as you can see, this also would not preview nicely. You have merged cells, different cells. And so what I would personally do here is that I would add a new field that says location. And then this one was Blewett. Here we're in Cranbrook, and so on, so that we can then delete all these merged cells, and they can each have their location. And so we'll be able to better know where those are and solve our issues with machine readability. So we can save that one. I don't see any more merged cells. I do see one. There's one more. Nope. Nope. Oh, there is. Okay. Um, but yeah, very quick overview as to how merged cells can really kind of cause us issues. So close that there. Then we're also interested in climate. And so I downloaded this from Environment Canada. It's got longitude and latitude, which is fantastic. Climate IDs, date and time, year, and so on, with a variety of different values and fields. So this one, as you can see, there's nothing really that we would really need to do here in order for it to be reviewable. But then again, it would fall into the hands of me going into it and making sure that it's looking good, that we know where it came from, and it's got all of its metadata accompanying it. Okay. Lastly, we have a logger file. So this one is from a temperature logger. And as you can see, there's various columns here, which would cause us an issue. So here, we have the first, just the time, the plot time, nothing in this cell, as it only continues from here. And so this will cause an issue. And what I would just do in this case is create a new sheet and call it metadata. This wouldn't be necessarily the metadata that you're looking at for the data set specifically, but there are things so that we can grab our headers, make sure that they're somewhere else where they're not going to mess with the preview of our data. And we can go ahead and remove these so that we have our plot number. We can just change that name, plot number, date, time, or temperature here, a little bit more information. So maybe this information is something that we can also put within our metadata. We can call this temperature metadata, paste it on there, make sure to save. And then if you remember from the example I did just previously here, we want a new column called units. And we know that these were centigrade, Celsius. No one says centigrade anymore. Now we have our units there. And then the coupler attached, the host connected, and the end of files information that can all go back into our metadata sheet. Okay, so now we'll just have to click save. And that will be previewable in our Water Hub. I did click save. Save that. And this one was already saved. And lastly, I have my report. As you can see, I didn't put much effort into my report, as it was just so you can see a little bit of the preview abilities for PDFs. So we can close that. And now we finally get to the Water Hub. After our hard work of formatting and looking into our data, we go ahead and log in, and voila, here we are. So we're gonna make a new data set. We go to our datasets page, and then we go to add dataset, and we're on our metadata page. Okay, so actually, if we go back, we remembered that we started filling our metadata before. So we can grab our Excel file, go to our dataset metadata. So it was Santi's project, and I'm kind of lazy, so I'll just copy and paste it. This is a citation. We can, it's not in here. So here we can cite it. So depending on what citation format you like to use, we're open to you choosing whatever you like, whether that's CSE or MLA, which for most of us will probably be using the Council of Science editors. And so you put it in that format, which I can't remember off the top of my head because there's things like Botero that make that for you. So this is a citation. Okay, our abstract. And so we did complete our abstract. And so we can go back here, copy it, paste it. This is a brief narrative summary of your data set. The location is where was this? And so we'll make, so we'll say that we did all of this in at Selkirk College. Why not? At the confluence of the Columbia and rivers at Selkirk College grounds. For example, data steward email, who is the person who is maintaining this data? So not who collected it, but who is in charge of this data, who owns it. So here, this is, I'll put myself, our data upload organization. So again, not who collected it, but who's uploading it. So who's responsible for it. And we'll look up, you can just start typing and your organization will come up. Living lakes, this is visibility. Now, this is a great feature that I really enjoy, as you can pick whether you have something private or public. So I want this one to be public. The data collection organization, we also have that one. And this was rather me. And so here I am, some information. So we went out and did blah and blah and blah with X and Y and Z in order to find A, B, and C. And I'm just making this up, and again, for the sake of time and simplicity. But please do be careful and detailed when you're uploading your data sets. It will make everything a lot easier. Data processing. So after collecting data, we did X and Y to it in order to find X plus Y, something like that. Any cleaning or QA/QC that was done. So this would be a good place to say formatting took place in order to have preview ability. And that's my word. Other data sources are here. I have BC Hydro, have Living Lakes, and others. A disclaimer. So this data did not go through QA, QC process. Here, we're really highlighting, making sure that our data users know that this data did not go through any quality assurance and quality control so far. And more than that, it lets me know that it didn't go through any QA, QC. And then here, for keywords, we're going to be using groundwater. We're going to be using meteorology. We're going to be using water quality. We're using water flow. And there's a variety of more that we can use, hydrometric too. So this is where you really get a chance to give a little more searchability for your data set. Our longitude and latitude, again, this is just very rough. I think we're at 49 point something. This is, looks like it might be in Casigar. And our, no, minus 107. There's 30 something, 117. Our elevation, we'll assume that this was done at, I think Casigar is around 300 and something meters above sea level. Data grade is not applicable, as this has not been reviewed by a qualified professional, and so it does not meet any data grades. Any other data grades, so if there is any other data grade that you adhere to, whether it be an ISO or anything like that, here's where you put that information. The data type, because we have a variety of different water flow, water quality, water level, and groundwater, we're gonna put it under other this time, because this pertains to the whole data set. And that's something to keep in mind if you're thinking of putting different kind of data within, or resources within one data set. Was this data QA, QC'd by anyone? So in this case, no. The start date of this, and so when everything started, when this ended, and our license. Again, we want the non-commercial as our standard. And we can go to add our data now. And this one we can get rid of, and I can make everything big. Okay. So here is where we're going to upload our resources. So first, I'm gonna go click all the things that I need here, and then you can find them wherever you have them. First, we'll go with the BC Hydro Flow. We'll open that. The name of the data, we'll call it water level BC Hydro. Header row, so it's going to be number 1, which kind of messes with my mind as I think in arrays, especially with Python. I would have named this 0. It's kind of weird that it's 1 to me. I kind of think with computers like that. And then we have something very interesting that we came up with. And this is the Waterhelp certified. And so at first, you're going to leave this as not certified. And once I have gone, or our team has gone through your data set, we're going to go in there and change this to certified. So this will say that your data meets the quality that we expect from our uploaders, and that will be outlined within our quality assurance and quality control protocol that we create. So for now, we'll leave it at not certified. This is an Excel data set, and any notes that may help people understand this. Like this is one of many resources on the environmental, let's call it environmental monitoring project. Oops, I can't spell today. Environmental project. And again, I'm just kind of making this up as we go. And then now we have more data sets. So save another one from our computer. We go to climate, open it again, same process before. Header row is number 1. It is not certified. It is an Excel file. Any notes? There's no notes on this one. Save and add another. And then I'm just gonna go through this really quickly now. So just do this. Groundwater, header row number 1. Not certified, Excel as well. Save and add another. Upload our logger file. Temp log. Please use full names. Header row 1. Not certified, Excel again. Any nodes. Save. Upload our water quality lab results for raw data. So here we can say raw data for lab results. Header row, we will leave that empty as this would not be previewable, as that was our original one that we received from the lab with the cover page in the first sheet. And it's again an Excel file. Save it on another. We only have 2 more to go. So now I'm going to find my water quality template here. Upload that. Here is the water quality risk. Ready. Header row number 1. It is not certified by us. This resource is completed in the template for the Water Hub. Just providing as much information as possible. And last but not least, we have our report, which is right here. This is report on findings. Our header row, there's no header row for this. It is not certified. And this is a PDF. And so here is where you'll be able to select all the different data formats for your files, whether it be a structured data formats of tables, tabular data, documents and images, PDFs. And here's our PDF. We'll walk through a little bit more of these data files. We have our geodatabases, our shapefiles, GMLs, geotiffs, KMLs and KMCs, as well as LiDAR in the form of XYZ. And pay attention with this one, it is not in a .las format. They are usually massive. And so this one's we're gonna have a little bit of a hard time with perhaps. You can also find MXDs, map packages for QGIS, layer files, R files, zip files, and others where you can explain in notes. So maybe you have a Python script, and so on, maybe SQL scripts, you name it. And a little bit of information, so this is a PDF, if I forget. And then that was the last one. We can go ahead and click finish. And now this is what I really enjoy, and I totally made a mistake here, actually. So let's go and edit this, because this came out as a PDF and not a CSV as it is, actually. Yeah, CSV. So go here, kind of separated. We update that resource, making sure that it's all good, and great. This would not be a presentation about data technology if there was not a server error. So I will look into that. So we'll deal with it as a PDF for now. And so here we can see that our project is nicely uploaded. We won't be able to preview this one, or we might in a very weird way. No, we can't. Great, and so let's see if we can preview this one. We also can't, and I really don't know what is going on here, guys. So, so yeah, ultimately this should all be previewable, and just like we saw yesterday with all the previewing capabilities. This would really make it so that we can see it, and I really don't know why this is not working right now. Oh, great, fantastic. So look at that, our risk-ready data set is what came up. And so here, this is great. We can see that the ID, the general field that is generated by Seekan was made, our data set name, our monitoring locations, the monitoring location name, latitude and longitude, and so on. You can also graph it, but we only have this much data, and so it wouldn't make any sense. Let's see if any other, can preview any other ones. Nope. Let's see if we can do it with this one. Great, so at least we can see the awesome previewability that we can do with PDF files. And so if you want to have your reports about the data you're looking at, you're going to be able to do it and have this ready, share in social media. And that covers our uploading and formatting. And so now I would like to move on to our Q&A, because I'm sure there are lots of questions to go through today. And again, a work in progress, and we'll continue to improve as we get to know you and your needs and the needs of the basin. And then the question from Adam. Interested for reference introduction to risk standards? We will do that, Adam. It is a lot. And we are still defining how we're going to carry out the data grading, as we'll need a registered professional to take over that. And so far what we're doing is setting the stage, I see it, as for us to be able to provide very high quality data for the basin. So I'll keep you updated for more upcoming webinars and how we can dive into this together. And it'll be a lot of fun. Okay, so now moving to Rory's question is, do remind me, is that a replicate of the WCOX metadata form that DataStream uses? Yes, Rory. I use basically everything that they did with their permission, and they're great because they're all open source. They provide all the templates open source, and I've really enjoyed working with them. And so, yeah, it is exactly theirs. I really think that their metadata standards and what they look for was very thorough, and I only had to add a couple of things in order for it to meet QA, QC ability. And another question from Adam, copy and paste fields. Are the date, times, and fields specified in one format? Example, why? Yes, they are. So you can see there was information on each field as you scrolled over it. And so that'll give you exactly what kind of format for you to use. And I'm still playing around with that, as right now we have it as in some fields there's date, time, there's like date and year, month, day format, and right next to it you have a time. And so we had to figure out what the best way to handle that is. If we want to have the times together with the date or not. And that will depend on how much you want to kind of be able to play with the filters and what you really be able to do with your data. Does that answer your question, Adam? Awesome. And we have a question from Richard. Does the spreadsheet check the date format? Yes, it does. It does on the water quality form. And because I created the water quantity form more on my own, I'm still trying to make that work on the water quantity. It's just been a little bit difficult really trying to emulate the work that DataStream did and did so well over a long period of time. We're kind of trying to catch up as to the amazing things they've done and following an example, because that's what open data is all about. We're building on what other people have built now. We're not trying to reinvent the wheel, but rather just make things easier for everybody. Okay, and I now have a question from Ekaterina. How does the spreadsheet handle non-numeric values below detection limits? So it handles it specifically as text. And it'll show up like that. So I'm not sure kind of what you mean by handling non-numeric values, as the database will still be able to preview non-numeric values. They'll show up just as text. However, you just wouldn't be able to carry on any kind of analysis on them if you're, let's say, looking at means for different like temperature values and whatnot. But it'll take text just as well. And there's still a little bit of formatting that I have to do in order to ensure that you can't put text in numeric fields. So just protecting the other way around, as numbers and text it can be funny to play with. So does that answer your question, Ekaterina? Okay, so another question from Richard is the data, apart from the date, all strings, or does it differentiate text from numbers? It differentiates text from numbers. And so I'm making sure I'm going through each field, making sure that whatever needs to be numeric is numeric, and whatever needs to be text is going to stay as text, and that is not going to kind of mess with our analysis that we do when we're trying to look into some things tomorrow. Okay, so now I have a question from Rory. Is for the water stage log, I found the form to be missing a section to calculate the offsets. I've augmented one that allows me to see all the offsets in one location. I recommend adding that calculation to the stage log. Thank you, Rory, very much for that, and I'll make a note for that right now, and I'm going to be reviewing all of these webinars also to make sure that we're not missing anything. But I really appreciate your feedback there. And now we have another question from Adam. Can one delete dataset in case a mistaken upload? Most definitely, and I can take you through that if you like as to how to do it. It's very straightforward. And you know what? I really don't like Santi's project. He went way over budget, and yeah, I really don't think he did a good job whatsoever. So I'm just gonna delete his dataset altogether. So goodbye dataset, and that was that. However, be very careful. There is no backseas directly. It might be a very, very difficult process to be able to go into CCAN to code and recover that. So yeah, just before clicking any red button, think about it twice or three times. Okay, so now we moved on to another question from Rory is, could you go into what you're thinking the steps will look like in regards to the review process? For sure. And so what I'll be doing is grabbing the values for from the manuals and the standards, and I'm going to have them right next to me, and I'm going to go through each field or do a search and find within each tabular data set that I'm looking at. And then I'm going to say, okay, so the values that are within this is what the province is telling me that is allowed. So I'm going to go making sure that all those values are within that. And eventually that's going to become an automated process as our data sets start to look more, what's the word, homogeneous, as they begin to really look as a Waterhelp standard or certificate where we can apply a script that will be able to go through all the different fields and say, yeah, okay, this data set good to go. Yeah, okay, this data set good to go. Oh, flag because temperature is 100 centigrade Celsius in this one data set. And so that's where then I will go and follow up with that. And so that's in the future, but right now it's going into it, doing some analysis to look for outliers, making sure that the metadata is complete, talking to the person who uploaded it to make sure that there's nothing missing, or they didn't need any help or troubles uploading it. And yeah, it's going to be pretty manual for the first month or so until we develop a way to automatically do it, which will then again will require a little bit more homogeneity within all of the data sets that are in the Water Hub. Does that answer your question, Rory?
Yeah, that does. It's maybe going to be tricky to do that. Like a lot of the things that you need to look at are in the metadata. So, I mean, maybe a bit harder to automate, but it depends on how deep you're going to go. But it sounds like you've got a plan. I was just curious mostly about like, are you going to get a qualified hydrometric reviewer on staff to be looking over data? Because I think you referred to that.
Yeah, so again, this is a work in progress, and part of this eventually is going to be the water monitoring collaborative. And so that's where we're looking to really have our certified hydrologist or someone who's classified to this and has the experience to do this in order to carry it out, because you need to be certified and there are standards for who can review this data. So there is going to be that step. And so we are not going to grade any data whatsoever for the first few months until we find the right person to do that for us. Again, what we're doing here is setting the stage. Setting the stage so that when this person comes here, all they have to do is come down on this data. Here's all the metadata and the forms that you need very nicely in a package so that the review process can be quick, so that we don't have to go back and search for metadata that might be lost now because we don't remember how to do it or how we did it, or it's just someone's hard drive got wiped, someone dropped their laptop, whatever variety of things, right? So I really think that this will eventually, that will be the case where we'll have a hydrologist review all of our data sets. And when it comes to the automation, again, it wouldn't be looking into the metadata, but just specific values within the actual tabular data itself. So just parsing through the Excel file and making sure that temperature doesn't go above 100 or DO doesn't go above something else. So metadata would be me weekly, systematically going into it and making sure that you're meeting every single standard that I as a data manager expect, and that we also define as a group in the collective to try and define what quality stands to, what quality is for us, because our understanding of quality might be different. And so that's going to be another iterative process where we can really say, yes, in the Columbia Basin, this is what we consider usable data in order for it to be used for all the studies that we're going to carry out, all the stewardship that we're going to carry out, and so on. So that's where we're at. Cool. So there is now a question from Anne and Roy. Many citizen science groups will have a small percentage of that metadata. Could there be a simpler form? Also, when adding data, will all of the metadata be redone? I am working definitely on kind of bringing down a little bit more of the metadata and make sure that we have like a standard kind of Waterhelp certificate. And that's what I was talking about when I'm going to go in and making sure that the metadata we're actually looking for is available for us. And again, an iterative process. We're growing and trying to meet the needs of the basin. And so we're slowly getting there, making this process, as I keep saying, really collective, and all the monitoring groups that might be involved in interest and that have a use for this have their word as to how they want to be best represented within our basin. So that'll be a work in progress, and I look forward to working with everyone in order to make that happen. And then I have a comment from Bill. I'm looking forward to working with you in January. Thank you. I also look forward to working with everybody. I didn't realize that was just to me, but yeah. So with that, and if there are there any further questions? All right. So with that, we conclude the second day in our webinar series, introducing the Waterhelp to you, our possible future users.